We are starting lesson 5. Students are working on the warm-up right now. I'm going to start doing it the way that I did, but keep in mind with these sum and difference ones, so that's what our warm-up here is, a review over the sum and difference formulas and how they can help us find exact values of any trig function of angles that are not like exactly on our unit circle, such as -5 pi over 12. Okay. So there's a lot of different ways you can do these though. There's a lot of ways you could rewrite -5 pi over 12 as a sum or a difference. So again, I'm just going to walk you through the way that I did it, but don't change yours. Let's just see if we get the same answer. So I always kind of think of this as like, okay, if I have something over 12 and I need to get a total of -5, 12, so -5 pi over 12. I personally try to keep like the angles positive because I think they're a little bit easier to work with. And if I need to get a negative, I'm like, okay, I'm probably just going to do like a difference. So I thought of this as 4 pi over 12 minus 9 pi over 12. Because I'm like, okay, well, 4 minus 9 will give me -5. And then that 4 pi over 12, that reduces to pi over 3. And this reduces to 3 pi over 4. So I'm like, okay, those are nice two like positive angles, easy angles to work with. I know Ashton did a different one. What was the one you did again? -pi over 6 minus pi over 4. So -pi over 6 would be, no, sorry, -pi over 6. Plus or minus, sorry. Minus pi over 4. That'd give you -5 pi over 12 as well. Okay. Did you have a different one?
Yeah, pi over 4 minus 2 pi over 3.
Pi over 4 minus 2 pi over 3?
Yeah.
Okay. So that'd be 3 pi over 12 minus 3 minus 8 would give us -5. Yep, that would work too. And I like that one too because those are nice positive angles. Okay, I just think those are a little bit easier to work with. Lots of different ways you can do this. Okay, so like I said, if you did it a different way, let's just see if we got the same answer. You're not wrong. Okay, now looking at my identity sheet. So I'm going to use these two angles. And if it helps you, you can rewrite it like this. Like, okay, this is the same as pi over 3 minus 3 pi over 4. So here's what I call like my first angle. Here's what I call my second angle. Looking at my identity sheet. Oh my gosh, there's not one for cotangent. Do you guys remember what we do? Oh, you remember. Sorry, he had his hand up, so I'll call on him. Carter.
Oh, yeah.
What do we do? Exactly, you do the reciprocal of the tangent one. Okay? So I see the tangent difference has that tangent of u minus the tangent of v all over 1 plus tangent of u, tangent of v. So my numerator for cotangent would just be 1 plus, and you keep it tangent. You keep it tangent. Yep, so that's a common mistake. So we're actually just like flipping the whole value here. And that's what the relationship is. Like their actual answers are reciprocals of each other. All over the tangent of u minus the tangent of v. That's how you do cotangent. You flip the tangent identity. Reciprocate, I should say. Reciprocate it. Okay. Now, again, the reason why we chose these angles is because now we can resort to our unit circle to find exact values for the tangent of pi over 3, tangent of 3 pi over 4. All right, team. Make me proud. What's the tangent? I'm going to come down here. What's the tangent of pi over 3? Root 3, yes.
I knew it. You guys.
I still have to look at my unit circle.
Let's start with this question. Tangent of pi over 4. Positive 1. So it's the tangent of 3 pi over 4. -1. Good. That's in quadrant 2. All over. Okay, we just answer this. All right, we got to clean this up a little bit. You want to hear good news? Those of you that when you take AP Calculus, you get to leave your answer like this. They pretty much say like, all right, you already proven yourself that you could do some algebra simplifying. So if you've done the calculus, you're done. That's the good news. So you have something to look forward to next year.
So it just gets easier after Algebra 2.
It does, but first we have to prove ourselves that we can simplify this.
I can.
Hey.
I got one.
My Algebra 2 students that are in here, we just learned this. How to rationalize this.
Dang.
Multiply the top and bottom by the
Right.
conjugate.
You guys are so smart.
We just learned it.
that.
Okay.
Okay. Like,
So hang tight, even if yours
oh, that's okay.
looks a little different because you use different angles, we should still get the final simplified answer the same. All right, up top I gotta distribute these. So let's see, that's root.
What was that?
I don't know, I kind of missed. Okay, are you done with those corrections? You can actually just put them in the red basket. Yep, and then I'll look at them. And if for some reason you need to fix some stuff, I'll talk to you about it, okay? So I'll fix that Alex assignment too, so that's all the criteria you need to do before you do your retake. Sound good? Because do you have all your homework turned in? I think you do. Yeah, okay. All right, sorry. Root 3 minus 1 minus 3 plus root 3 all over conjugates, just multiply first and last. So 3 minus 1. Okay, so I have 2 root 3s minus 4 all over 2. Hard it up. Oh, yeah, I always forget about that. Is this all I'm supposed to do like that?
Sure. It doesn't matter. I think
Root
it's funny.
3 minus 2.
Oh, wait, I got it right. Okay, wait. Can I show you what I
was
did?
actually.
Can I show you what I did? Can
Okay.
I just write it on the
Oh,
board?
yeah, come on up.
Okay.
Did you do it yourself?
No, because this literally took like 2 steps.
Don't drop the markers.
Instead of doing all of this, this is what I did.
Oh, interesting.
So we had negative 5 pi for 12.
That's a beautiful pie.
Okay. And then I just wrote it like this.
Are you a lefty?
Yeah. I just wrote it like this. And then I just found the values for those, which is
Oh, yeah, you have two.
that's it.
That's
Negative
No.
root 3.
yeah, that's not always gonna work. That's why we have these identities. It's not just the same as taking the cotangent and then cotangent.
Wait. No, okay.
It's
okay.
okay. Sometimes you need to see non-examples. Here's one.
I didn't.
It's okay. All right, let's see here.
Wow,
Cotangent.
that was hard.
Jackson, mine's a minus
You
2.
did it yourself, didn't you?
But you screwed up
Mine's a
again.
minus 2.
It's okay. It's okay.
He said at least they get.
You are gonna be featured in my YouTube video, but it's fine.
It's featured in my YouTube. Oh, I want to stay now.
So let's see. I think here there'd be 2.
Okay.
That's all you did wrong.
It's so close.
The other math is right. Okay, but actually, guys, this is a great example of like why we have these identities. It's not as easy as just taking the cotangent of one times the cotangent of the other. It was close, but
This is a great example of what
sometimes it does help to look at non-examples, and that was one.
It was deceptively close.
Yes. Okay. I appreciate you trying to find a shortcut, but don't cheat the identities.
The calculator does it all the time.
Yes, ma'am.
Do you guys remember how we could check this in our calculator?
No.
All right. Let's
Plug it in.
So make sure you're in radian mode.
I didn't bring my calculator.
Oh my gosh.
It's Monday. I'm tired.
One of the old school teachers at McGonigal would take points off of students if they didn't show them their calculators.
Really?
He was like very.
That sounds like a glass
He
burner
was like,
thing.
"This is a materials check day. If you don't have your calculator, you're losing 10 points."
I can take
Yeah, you sound like something, Mr. G.
10 points. Out of how many?
Okay. Here's how you can check your answer. That's calculus. You can
That's illegal. That's what that was.
you can take the cotangent of negative 5 pi over 12, which you do as 1 over tangent of negative 5 pi. I always like to write my numerators and divided by 12. Okay, that's the same as taking the cotangent of negative 5 pi over 12. Obviously, it's not going to give us the exact answer, but we could type in what we got. We got the square root of 3 minus 2, and those decimals should be the exact same.
That's pretty neat.
Pretty easy.
That's how you check.
That's
Bless
you.
you.
Wait.
And I still didn't
Did you get the square root of 3 over 2 minus 2?
I just did it the way you did.
Oh, sorry. Did I start too soon? I didn't give you enough time. All right.
Well, I didn't go ahead because I knew I did something wrong at the beginning because I had them still coding.
Got it. Okay, that makes sense.
But I vote we just put them in decimal form, so we can just type it in our calculator. We don't.
I wonder if
Or you see
Because
why I take
decimals-
cheat calculator.
sometimes decimals, you guys have decimals.
Yep.
Sometimes it gives you like zeros in exact form. Does it?
Bro.
Or is it? No, it doesn't. No, it doesn't. That's a lie. I was like, I wonder if you type this in decimals if it would give you the exact answer. I don't know.
I don't think it does.
Okay. I'm going to introduce you to a couple new identities to add to our trig identity family. And we're just going to do a little mini proof, if you will, but these next ones come from the sum identities, which we already know, okay? So if you look at your identity sheet and you go over to the right-hand column, you see the double angle formulas?
Oh,
Oh yeah.
That's what we're going to learn next.
can we just never do a? Oh wait, no, those are all
Double
equals,
angle
never mind.
formulas. So if I have the sign, and we solved equations like this. We solved equations that have like multiple, like a factor being times to the angle, okay? So if I have the sign of 2 times some angle theta, let's rewrite 2 theta as a sum. That's the same as theta plus theta. Agreed?
Yep.
Sure.
Theta plus theta is 2 theta? Just like any other variable? Okay. So we can actually derive, or kind of like prove, where this double angle formula comes from by using our sum identity. Okay? So, as always, on my journal, I'm never going to ask you to like prove this on a test or quiz, but it's good to have a little appreciation of where these identities come from, and they're on your cheat sheet, so you'll get these identities. You don't have to memorize them.
Stop.
Thank you for this, by the way. Again.
I never agree.
All right, so here's kind of like your U and your V. So when I have the sign of a sum, that's the same as the sine of the first angle, which is theta, times the cosine of the second angle, which is theta, plus the sine of the second angle, which is theta, times the cosine of the first angle, which is also theta. And you're like, okay.
Okay.
So if I have 1 sine of theta times cosine theta plus 1 sine of theta plus times cosine of theta, we have 2 sine of theta cosine theta. Do you guys see how that's the double identity for sine? 2 sine u cosine u. There you go. There's where it comes from.
Wait, can you sign that again?
But you're
Why'd you just get a
adding
random cosine?
Yeah. So if you have 1 plus 1, you have
So you
Two.
use the sum or
Oh.
difference formula, and then you win.
Oh,
the-
okay, I see.
again. You'll be given that this is equal to that. This is just showing you like why they're the same.
Why do we just
I'm being 100%.
I use the double angle, or I use the I use the sum identity.
Oh, it's a big party. Smells like oyster.
Look at your identity sheet. Do you see the one that says sine of u plus or minus v under the sum and difference formula?
Yeah.
Okay, so I rewrote 2 theta as theta plus theta. So using that identity, looking at that one, it's the same as doing the sine of the first angle times the cosine of the second angle
Boys behave.
plus, I guess I rewrote these, sine of the second angle times cosine of the first angle. I just use that identity. This is what the identity says, but I rewrote it so you could see that they're like terms, which that's obviously the same as this. Okay. So same idea here. We're going to rewrite this as cosine I should like number these. So I'd be like, everybody look at identity 4B. And then you guys know which ones I'm pulling from. Okay, sum and difference formulas. Left column, almost to the bottom. See the one for cosine? Okay, so here's my u, and here's my v. So I'm using that identity. It is the same as the cosine of u. Now I know this is a little weird because you're like, well, u and v are the same thing, and that's kind of the point. I'm showing you why this double angle identity simplifies to what it does. Cosine of the first angle, theta, times cosine of the second angle, which is also theta, minus sine of the first angle times sine of the second angle. All right, that's just from the sum identity.
Oh, what? I'm
One
done.
B.
Wait, good momentum. Well, okay, never mind.
Okay, now what's cosine of theta times cosine of theta?
Squared.
Squared.
Cosine squared of theta, and
Right.
same for the sines.
Yeah.
All right, now here's kind of the weird thing.
It equals another one.
Look over to the double angle formula, and I have these in your notes here too, but I'm just showing you on your identity sheet. There's two separate identities for the cosine double angles. There's two different ways that we could rewrite
There's
the
three.
double angle identity. Well, yeah, technically yours has three. So here's one of them. We already came up with that one. Cosine squared minus sine squared. There's one of them.
You have to keep everything up too?
Yeah, but it's not hard. Here
not
we're just
hard,
gonna
it's
substitute.
difficult.
Here, let's go one way. I'm gonna use my Pythag identity and rewrite cosine squared as 1 minus sine squared. So I'm essentially just changing everything to sines. Okay, so I'm just using my Pythag identity. Hopefully we're kind of starting to recognize the sine and cosine one because that comes up a lot. Okay, so then I end up having 1 minus sine squared minus another would be minus 2 sine squared of theta. There's the other one. There's this one. Okay, so where this one comes from is if we change the sine squared into terms of cosine. So I could keep that first cosine squared the same. I could change that sine squared to 1 minus cosine squared. Pythag identity, same idea here. All right, so here I have cosine squared of theta minus 1 plus cosine squared of theta. I'm going to write it in the same order that yours has. Okay, so it has cosine squared plus cosine squared would be 2 cosine squared of theta minus 1. There's that third one. Oops. Okay. There's that one.
There it is.
Now for tangent, this one's not bad. Okay, we could rewrite this as theta plus theta. Okay. Left-hand column, sum and difference formula for tangent. In this case, a sum. Here's my u, here's my v. That is the same, according to this identity, as the tangent of the first angle plus the tangent of the second angle all over 1 minus tangent of the first angle, tangent of the second angle. Do you guys have these memorized by accident yet?
No, not by accident.
These ones are
kind of the Pythag ones.
The Pythag ones? Those ones are more important. All right. Up top, I have tangent of theta plus tangent of theta, which simplifies to what?
Tangent of
Theta.
2 tangents of theta. And on the bottom, I have 1 minus tangent of theta times tangent of theta, which is tangent squared of theta.
Why did it?
And look over at the double angle formula. Hey, there it is. That's where it comes from. Right there. Okay. So that was just basically a little mini proof of these identities. Now, I like to show these for 2 reasons. If you're ever in a panic where you don't have the identities with you, and you're like, well, I have the sum and difference ones down. I know those. I know my sum and difference ones really well. I think you guys could all handle like going through that, like rewriting it as a sum, and then hey, if I know these ones, I can figure them out. But like I said, I'm always going to give you these, but here's a little appreciation of where they come
It
from.
might take you an
Yeah,
hour.
Jackson.
It might take me an hour to figure it out.
No,
But that's
good.
okay.
No,
Yes,
Okay. So we have solved equations with multiple angles using identities before. But now since we have these double angle identities, there's like an easier way to do this. And especially when I have something that's in terms of two different trig functions. Okay, so looking at this one right here, I have 2 cosine of x plus a sine of 2x. And I'm like, I'm trying to think of identities I could use. I was like, I don't see anything being squared. You know, last lesson we did move like cosine to one side, we like squared both sides, and then we had to worry about extraneous solutions. So now that we know these double angle formulas, you can be on the lookout. And again, double angles, because you're timesing the actual angle by 2. You can try and see if these double angle formulas will help you. Okay, so if I see this, it says solve the equation. It doesn't say on the interval from 0 to 2 pi, so I'm going to have to add in like that plus or minus 2 pi n. Okay, just like before. This is a good review for our quiz on Thursday. And I see I have the sine of 2 times x. So looking at my identity sheet for that double angle formula, like, hey, I know that that is the same as 2 times the sine of x times the cosine of x. Okay, everybody okay with where I got that? Right from the identity sheet. Honestly, folks, this lesson, it's just a lot of like plugging and applying the identities. It's really a lot of like using your cheat sheet and just plugging stuff in. Okay.
It's great.
If you like that stuff. And now I'm like, okay, this looks a little bit better. I still have sines and cosines. Any ideas? Okay. Factor out what? What do they have in common?
Cosine is 2.
2 and cosine x, okay? So ultimately, like what Wally said, like you could try that, subtract over, and then you're like, well, I have sines and cosines, and now there's cosines on both sides. Is there a way I could like square both sides? Like you could try that. It's going to get pretty messy. But if you recognize like, hey, how would I normally solve this? I'd probably try to factor something out. This is one of our algebraic techniques. So what's common is 2 cosine of x. That would be 1 plus sine of x equals 0. And then I was like, okay, this looks a little bit better. ZPP, zero product property. Now I have 2 separate little equations, and I'm like, oh, I could definitely solve these. Yes, you can, Carter. Divide both sides by 2. Minus over the 1. Unit circle. Which angles? Give me a cosine value of 0. Okay, now I know it doesn't say just on the interval 0 to 2 pi. I'll fix that in a second here. Which angles does sine have a value of -1? Pi over 2 is positive 1. 3 pi over 2. Okay, so how we can write our list of all the answers is we can do pi over 2, 3 pi over 2 plus or minus, since this is sine and cosine, 2 pi n. That's technically not wrong, but there's a way we could kind of condense this and write our answer in like a more simplified way. Anybody recognize how else we could write this? Think about what you're saying there. You're saying pi over 2, 3 pi over 2 plus or minus another 2 pi. Idea, Natalie? Good. We could also say, so what this says is like, it can either be here or here plus a multiple of 2 pi. Plus a multiple of 2 pi. Now we said, well, why don't we just say pi over 2 plus or minus pi would get us here, plus pi. So I'm okay with this answer. if you're checking your answer in the back of the textbook, this is technically a more condensed answer. This is a better answer. I'll just say condensed. That says the same thing. Okay? I'm okay with us getting to here. This demonstrates to me that like you solved this correctly. This is just another step further and then making your answer a little bit more condensed or a little bit more simplified, okay?
Okay. I guess.
All right. Write small on this next one.
Oh,
I ran out of room on my
you're
paper.
such a fun teacher.
Aren't I funny every day?
You're special.
Hysterical.
I'm especially funny today. All right, thanks.
You lie. Oh.
So you might be tempted to do a couple things. You might be tempted, you're like, I see cotangents and tangents. Should I try to change everything to sine and cosine? Should I try to change cotangent to 1 over tangent? And there might be other ways you can go about this.
Use the double angle.
But yes, we're working on the double angle formula. So hopefully kind of your first instinct, and I think the directions in the textbook might even say solve the equation using the double angle identities, I think. I see the tangent of 2 times x. I'm like, okay, we just learned this identity. Let me see if this would help me. Tangent of 2 times an angle is the same as 2 times the tangent of that angle all over 1 minus tangent squared of that angle. Okay, now from here, there's lots of different ways you could go about this. I actually did it like 2 different ways, and the first way I did, I was like, that was, I think, more steps than the second way I came up with. So keep in mind, like, there are different ways you can do this, as are a lot of these identity problems. So I found the shorter way was to move this 1 minus tangent squared to the other side, so times both sides by. Okay, so essentially that gets rid of that, and then I have 2 tangent of x. Okay, let's go through this math quick here. Obviously, cotangent of x times 1 is cotangent of x. Ooh.
Let's just say it's a tangent of x.
How did you know that that's the same as tangent of x? You're right. That cotangent times tangent squared. Yeah, how'd you know that?
Is the reciprocal.
Yeah.
It cancels.
Exactly. Think of
She asked me and she
cotangent as 1 over tangent.
Whatever.
I am.
It's okay.
The tears coming out of my eyes.
We're all pre-calc friends here.
Nope, too tired for this.
I don't like these people.
Wow.
It's unfortunate.
It's okay.
Go to a different class. I know what's happening.
Oh,
I can't.
Oh, we got it.
okay.
You want to?
Hey, you stop.
If you don't have anything nice to say,
Take a deep breath.
what did I have to say?
You tell them. Happy Mondays.
What am I doing in my 3rd grade? Like, be nice thing.
Now I get
We're
here.
all stars.
And again, a lot of different ways you could go about this, but one thing I recognize that I had 2 tangent of x over here. I could move this one over and get 3 of them. And I'm going to simultaneously move this cotangent over as well. And I'm like, okay. It's looking a little bit more condensed. You're like, it looks pretty similar to where we started. So then from here, I did common denominators. So I know cotangent of x is 1 over tangent. So I took this one, made common denominators. And I get here. 3 tangent squared of x over tangent of x minus 1 over tangent of x. Now we have common denominators. So we're here. Okay, now what I'm actually going to do is I'm going to essentially kind of like factor out this tangent because I'm going to use ZPP really soon. Now this isn't necessarily like tangent in my numerator. This is technically down here 1 over tangent. Or you can kind of think of it as like you're splitting up this fraction. We've done that a couple times. And the reason why you have to do this is because we do get, smartboard's kind of tweaking out. It's because 1 over tangent is the same as cotangent. And we do actually get some values where cotangent is 0. Okay? So this is the same as cotangent of x. That could be 0. That could be 0. So I kind of did like a 0 product property. Okay, so a common question people often ask is like, why couldn't we just multiply both sides by tangent of x? The reason why is because in case you're in case you have an angle where tangent is 0, you technically can't, I know we're timesing both sides, but you technically can't like divide the equation by 0 because this is like a variable. It's kind of like this. Let's just say something like this. You're like, oh, let me just divide off an x on both sides. I only get, oh, that's a bad example. Let me try something else. Where would x be 0? Okay, let me try this. So we factor this out. You're like, oh, let me just divide both sides by x. Don't do this. This is another non-example, my friends. And we just get 1, but we miss that solution that x could also be 0, and technically we just divided both sides by 0, which is a no-no. So it's kind of along that similar thinking here. And again, I know we didn't divide both sides, but because we do have 1 over tangent x is the same as cotangent of x, and there are some angles where that is 0. So if we technically would have divided off that cotangent of x on both sides, you would have been dividing by 0 because there are some angles that give us a value of 0 there. So when in doubt, like kind of like factor. Now, if it's just a plain old number down there, if it's like a 3, obviously you can times both sides by 3 because you know that's not 0. But if it's something that involves a variable, just be careful that you're not dividing both sides by 0. Does that make sense? Because this is technically cotangent of x. So if I would have divided both sides by that, I'd be divided by 0. Because there are angles that when I take the cotangent of it, I get out 0. Pi over 2 and 3 pi over 2. Again, I know that we'll have to write it this way in a second. Tangent piece of this told you to write small. When I square root both sides, what do I need to do on the right hand side? Plus or minus. Don't forget about that. Plus or minus. So I'm asking myself, I'm going to rationalize this this is the same as root 3 over 3 if it helps you to see it like that. Which angles, when I take the tangent of it, do I get positive root 3 over 3 or negative root 3 over 3? All of basically like the reference angles of pi over 6. All like those ones that are pi over 6 units away. Okay. So my final answer here, cotangent, tangent, remember those ones have periods of pi. So you have pi over 2, 3 pi over 2, pi over 6, 5 pi over 6, and we can just say plus or minus pi n, and that would hit those two angles. Now again, if you listed them, that's fine. List them again. I wouldn't take points off because I can see that you got all of them. But pi over 6 plus another pi, that's 7 pi over 6. 5 pi over 6 plus another pi, that's 11 pi over 6. So this would be a good condensed answer. Okay, yes. There are no extraneous because we never squared both sides. We only square root. Yep, it's when you square both sides. Good question. Extraneous solutions come up, and this doesn't come up a whole lot that you have now that especially we know other identities. This doesn't come up a whole lot, but if you square an unknown, which in math we use letters for that, if you square a variable, that's when extraneous pops up. Good question. Okay, told you that one was a.
That's
Hold on.
good place.
I think it's a good place to stop.
I already printed off a new one, so I can rewrite it either. No, let's keep going. We'll do at least one more problem.
Awesome.
All right, use the given conditions to find the exact value of the sine of 2 times u, cosine of 2 times u, and tangent of 2 times u. They don't even tell us what the angle is, but they give us the sine value for that u angle, and they tell us what quadrant the angle's in, according to this. Which is which quadrant, folks? 4. Okay. Now we're not going to use the inverse button in our calculator. We're just going to draw a picture. We know this angle's in quadrant 4.
That's. Never mind.
And we know the sine of this angle is opposite over hypotenuse. And I'm going to treat that like a negative 12 because we're here in quadrant 4. All right, Pythagorean triple. What would this sine length be?
5.
5. Nice. Positive or negative 5?
Positive.
Positive because we're in quadrant 4. Okay. We've done a couple of those. So we know the sine of this angle is negative 12/13. So if I want to find the sine of 2 times this angle, or double that angle, is another way to phrase that, using that new identity, I know that's the same as taking 2 times the sine of u times the cosine of u. Well, I know the sine of u is negative 12/13. And now that I have this picture drawn, I could figure out what the cosine of u is, which is 5/13, adjacent over hypotenuse. So we pretty much did that without even figuring out what the angle actually is by drawing a picture. Okay, that reduces to negative 120 over 169 for sine. All right, now the double angle identity for cosine, we have some options of which ones we want to use. Any ideas of which one would probably be like the best idea to use? The one with sine squared, because we were given that. So in case we made some mistakes over here, we were given what sine is, so I'm going to use that double identity. That cosine of 2u is the same as 1 minus 2 sine squared of u. And you're like, all I need to do here is plug in that value they gave me, which was at negative 12/13. Okay, you could literally type this on your calculator, order of operations, x1 times a 2. I got negative 119 over 169. Couple ways you could do tangent. You could just do sine over cosine if you wanted to. That still works for the double identity. I'm going to use the double identity just because we're kind of practicing using these identities. That's the same as 2 tangent of u, 1 minus tangent squared of u. And you're like, oh, well, I can easily find the tangent of that angle. Oh, shoot. You guys were right. We didn't have time. Okay, we'll finish this. Tomorrow, ACT day. Definitely a 3-dayer. Okay.